video, I want to talk about dimensional analysis. And so let's first off start with a little graphic I have on a PowerPoint. So in dimensional analysis, you have a given quantity, and then you have a conversion factor. And that gives you your final answer, and that gives you the desired unit, right, that you want your answer in. So the answer choices or your teacher will specify the exact units that they desire in the problem. But let me show you how units cancel, or how to get units to properly cancel in dimensional analysis to get that correct final desired unit. You have your given unit times your desired unit over your given unit, and then notice what happens. Your given unit here in the numerator cancels, your given unit in the denominator cancels, so that gives you a final answer of your desired unit, right? I don't think I have another example here. It's just that. So you need to look for cancellations, or even dig in your mind to learn or to see that if you know any conversion factors that would help you to cancel out a unit given to you in order to get that unit in the final desired unit that you want in your problem. Let's work a couple here on this worksheet. So number 6, Grandma is in her Lincoln Town Car driving 147 kilometers per hour. What is her speed in miles per hour? Now I give you a conversion factor. Some of them you'll be expected to memorize, but others you won't be. 1 meter is 3.28 feet. And 1 mile is 5,280 feet. So you should always appreciate it when problems give you conversion factors, because that's going to help you and guide you in figuring out the exact steps you should take to get to that final desired unit. So in dimensional analysis, one of the greatest questions that I get is, how do I start? That seems to be the most confusing thing for students, is learning how you start and how you build your cancellation table properly to get to that desired unit. So let's start off with what we know. That's what we always begin with, what we know, and that is what we're given. Let me switch over to this black ink here. You have 147 kilometers per hour, 7, and then I write it this way, my units, kilometers per hour. At least I write it for the very first one. Then I'm going to block it off and go on. Actually, let's write a little bit clearer. Let's say kilometers per hour, so we'll put hour on the denominator. That's the exact same as the way that I had it written before. So you always start with what you know, with what you're given. And so I can either start off by canceling kilometers or hours. It's your choice, right? Because kilometers and hours, well, actually kilometers is not in mph, miles per hour. But hours here is in miles per hour. So excuse what I just said. You want hours in your final answer, but you don't want kilometers. You want miles. So we need to cancel out kilometers and somehow replace it with mile. So how do we cancel kilometers? Well, here in the given, it's in the numerator. So to cancel out, kilometers is going to have to be in the denominator. And so that automatically cancels the unit of kilometer out. Notice that the problem gives you meter and then to feet. And so you know then you need to convert kilometers here to meters. And it's very simple to do. You should have this memorized. In your textbook, I guarantee you, has a table. 1 meter is equal to 0.001 kilometers. So now we're out of kilometers and we're in meters. Now let me make it clear. We're canceling out kilometers because kilometers is not a unit in the final answer. Hours, on the other hand, is a unit in the final answer, so we want to keep that. And just in case you missed it, the reason that I went from kilometers to meters was because meter is given to you in the problem. That's meant to not only give you a conversion factor in case you don't know it, but to help guide you along. Let's move to the next step because we're not done. Meters is still nowhere in the final answer. Notice capital M is miles, lowercase m is meters. Well, how do we get the meter out? It's in the numerator. Let's put it in the denominator. So automatically it's canceled. So we know meters is the denominator. And lucky you, you're given that 1 meter is 3.28 feet. So then we can just write down what we're given. That 1 meter is equal to 3.28 feet. Perfect. Again, we use the values they give us as stepping stones. Moving on, though, we know that feet is not in miles per hour. So we need to get rid of it. We'll put it in the denominator. And notice, since you have it in the numerator and the denominator, feet gets canceled. And you are given that 1 mile is equal to 5,280 feet. So this problem gives you nice stepping stones. But again, later on, as you get more advanced with this, you'll either have to Google the conversion factor or memorize it, depending on what your teachers are going to do for the exam. We know then that 5,280 goes on the bottom. Again, because you have 5,280 feet, and you had to put feet here in the denominator to cancel out feet in the numerator. And the problem gives you 1 mile. Or let me keep this constant. 1 mile, we'll make it capital, is 5,280 feet. And so now let's look at our units. We have miles on the top, hours on the bottom. And that's perfect because that is miles per hour, or M over H in this case. So we've solved the problem. Now all you need to do is take a calculator and multiply every number in the top row, multiply every number in the bottom row, and then divide the two. And that's going to give you 91.3416 miles per hour. So grandma's going. You can round that to 91.3 miles per hour if you would like. Let's move over to the next problem. This problem is good, but it's not good. This is assuming that the date was August 25th, and that's because when I worked this with my class, that happened to be the date. Here's the deal. You had this particular engine that was produced in 1971, and let's assume that it was August 25th of 1971. How many hours ago has it been since August 25th, 1971? So this answer will change every hour for eternity as long as this video is on YouTube. Let me make it clear. I'm doing this video, let's just pretend it's not August right now, but let's pretend that it is still August 25th for continuity. And I'm going to say today is August 25th, 2018. So if you're watching this video in 2019, 2020, or 2050, you'll have to change this date to make it correct. Let's set up the dimensional analysis problem using the same cancellation table as I did in the previous problem. So again, the hardest thing for a lot of students is, how do I know where to start? You always start with what you're given. And the only thing that you're given is the date. Right? So you need to start with what you're given. How long ago has it been from 1971 to 2018? Right? And so that has been 47 years. So we know we have 47 years, and we'll start the table. And so think about it. It's easy to go from years to days to hours, right? But we don't want years, we want hours. So we need to write years in the bottom here, and that'll cancel it out because, again, years is not a desired unit. How about days? That's a nice way to simplify it. We know there's 365.25 days in 1 year. That's perfect. But again, we don't want days in the final answer, so we need to put it in the denominator since it's already in the numerator. We know there's 24 hours in 1 day. So look what happens. The years and days have been canceled, and all you have left is hours. If you multiply this straight through, this will give you the correct number of hours for 2018. Number 8, I'd show you what you need to do. Convert 300 milligrams to ounces. What do you start with? You start with what you're given. And you also need to realize this is a clue. But if we start with what we're given, that's 300 milligrams. And we know that there is 1 ounce and 28.35 grams. But notice this says grams. This does not say milligrams. So we need to convert milligrams over to grams to be able to use this factor that they gave us. So you should be familiar with how to do this. Some values you just have to memorize in the metric system, and that is 1 gram is equal to 1,000 milligrams. Now, why did I write milligrams on the bottom? Because milligrams is not a desired unit. Grams is. So since milligrams is on the top, here I need to put it on the denominator here, and that will cancel it out. Now that we're in terms of grams, we can use a conversion factor. 1 ounce is 28.35 grams. Well, notice, again, grams is not in the final units. You want ounces. And so grams will go on the bottom, and ounces will go on the top because grams will cancel. 1 ounce is 28.35 grams. Notice you want milligrams to ounces. Every unit in this cancellation chart has been canceled except for ounces. And that will give you 0.0106 ounces for your final answer. I'm not going to work number 9 just to save you time, because if you can work number 7, you can work number 9. Number 10, how many mils are in 2.54 liters? Well, again, you need to memorize some of these conversion factors. What do you start with? What you're given. You have 2.54 liters, and you know that 1 milliliter is equal to 0.001 liters, right? So it's by a factor of 1,000. And so that equals, by the way, notice I put liters on the bottom because you want milliliters in your final answer, so you need to put liters in the denominator to cancel liters in the numerator. And so that's going to equal 2,540 milliliters. Notice, though, that the answer choices are in scientific notation, and if you watch my video on scientific notation, you'll know that it's 2.54 times 10 to the 3 milliliters. Notice something. Milliliters is not written capital ML. It's not written capital M, lowercase l. It is written lowercase m, capital L. I hope this has been helpful for you, and I'll see you in the next video.